Good morning, everyone. In this class, we are going to discuss about our ocean density. Okay. Now, what is ocean density? Density is the mass of a substance per unit of its volume. That is mass per unit volume. In simple terms, it's a measure of how tightly packed the matter in an object is. For the ocean, this single property is one of the most important physical phenomena. It controls the large-scale movement of water, forming the currents that shape our world. Understanding density is the key to understanding ocean circulation, heat distribution, and even the health of marine ecosystem. Okay, density is equal to mass divided by volume. Okay, mass per unit of volumes. Okay, drives ocean currents, mixes nutrients and heat, regulates climate. Now, salt is the first and crucial key to the ocean density. The primary difference between ocean water and fresh water is dissolved salt. These salts add mass, making seawater significantly denser. Okay, this is the fresh water and it has less amount of salt, and this is seawater, it has large amount of salt. Because of this salt, this water contains higher density. Okay, higher density provides more buoyant force. That's why the egg was floating over this water. Okay, fresh water, 1000 kilogram per meter cube it is the density of fresh water, and in seawater 1020 to 1029 kilogram per meter cube. Okay, it is the density of ocean water or seawater. Now, the density of any parcel of seawater is determined by a combination of three key properties. We can remember them with a mnemonic TSP. TSP means three C properties. What is this? T for temperature, S for salinity, and P for pressure. Temperature, salinity, and pressure. These are three key factors of ocean density. Okay, number one, temperature. As temperature increases, water expands and its density decreases. Okay, if the temperature increases, the density decreases. As temperature decreases, water contracts and its density increases. Okay, if temperature decreases, the density will increases. Warm water, molecules move faster and spread apart like this. This lighter water tends to rise or stay at the surface. Example, equatorial ocean water. And cold water, molecules slow down and pack closer together. This heavier water sinks. Example, polar ocean water, like this. Okay, warm water has low density and cold water has high density. The second variable of controlling ocean density is salinity, that is salt, amount of salt containing in the ocean water. As salinity, the amount of dissolved salt increases, the mass within the same volume increases. Okay, if the salinity is increased, the density of the volume will increase, causing the density to increase. Okay, volume also increase and the density will increase. Okay, dissolved salt, primarily sodium and chloride, fit into the spaces between water molecules, adding mass without significantly increasing volume. Waters in regions with high evaporation like the Red Sea and Mediterranean, or where sea ice forms, becoming highly saline and therefore very dense. That means if the water contains high salinity, the volume will increase accordingly, and thus the density of the water also increases. The another controlling factor of ocean density is pressure. As depth increases, pressure increases. This immense pressure slightly compresses water molecules, causing density to increase. That means in the outer portion of the sea layer, low pressure, and the depth, high pressure, and the medium pressure. Okay, as we go down to the depth of the seabed, the pressure will increases. While the effect is minor near the surface, it becomes a major factor in the deep ocean basins. This effect contributes to the extreme density of deep sea water, which can exceed 1050 kg per meter cube. This high density helps keep deep ocean layers stable. Okay, that's why due to this high pressure, the deep ocean water is stable. Now, this is a comparison table: temperature, salinity, and pressure. Okay, temperature and increase in this factor causes water to expand, and temperature effect on density decreases, and temperature, example location, equatorial oceans. Okay, that means temperature causes water. If temperature will high, it causes water to expand, and density will decrease. Okay, if salinity is high, adds more dissolved mass and density will increase. Example, Red Sea and Mediterranean Sea. And if pressure is high, compresses the water with depth. Pressure is high, density increases. Okay, deep means deep. Example, deep ocean basins. Okay, cold salty water is the densest. That means cold, that is temperature cold, and its cold water also creates high pressure. Cold as well as high pressure and salt water is denser. That means dense ocean water. The interplay of solar heating, freshwater input and evaporation creates a complex pattern of ocean density. Surface waters are generally lighter than the deep ocean, but density also varies dramatically by latitudes. For example, high density, extremely cold temperature, high salinity from ice formation, that's why it's high content, high density, that is 1029 kilogram per meter cube. And on the other hand, on the equatorial regions, high temperature and high rainfall, that's why it's content low density. In the ocean surface, ocean components, that is 1020 kilogram per meter cube. Now, the densest water masses are formed in the polar regions through a process called brine ejection. As seawater freezes from ice, most of the salt is left behind in the remaining liquid water. This water becomes intensely cold and extremely salty, causing it to sink to the ocean floor. Okay, step 1, freezing begins. Step 2, brine ejection. That is brine ejection. Brine ejection means the ice. That means the freezing water, that is freezing water, ice reject its salt contents towards the nearby water, surrounding water portion, and that's why it's called brine ejection, and it gets sinking. In the North Atlantic deep water from near Greenland, Antarctic bottom near water, the single densest water mass on the planet. These are two examples of this brine ejection process. These density differences are the engine for a massive continuous planet-wide circulation system known as thermo-haline circulation. Thermo means heat and haline means salt or salinity. This system moves vast amounts of water and heat to carries around the globe. The global conveyor belt is far more than just moving water. It is Earth's primary climate regulator and nutrient delivery service. Okay, there are some significant of this ocean density circumstance, ocean density characteristics. First of all, climate regulations. It helped in transports immense amount of heat from the equator towards the poles, moderating global temperature. That is global conveyor belt. And it also increases the nutrient distribution, pulls nutrient-rich deep water to the surface, upwelling, fueling marine ecosystems and supporting fisheries. Then weather patterns influences long-term weather phenomena like El Nino and La Nina, and regional climates like the monsoon. Okay, these are some crucial or significant impacts of this global circulation. Global circulation means heat and ocean density. Okay, ocean density as well as heat and pressure. Now, because dense water lies below lighter water, the ocean is structured in stable layers. The boundary where density changes rapidly with depth is called phenocline. This permanent stratification acts as a barrier separating surface ecosystems from the deep ocean. Okay, this is surface mixed layer, lighter, warmer, less safety, and this is deep ocean portion, denser, colder, and saltier, and this is the phenocline, or where rapid density change. Okay, this portion contains density change rapidly. Rapid density change. Now, understanding the principles of ocean density is essential for a wide range of scientific, commercial, and environmental activities. For example, climate forecasting, predicting patterns like El Nino and long-term climate change. Marine biology, explaining the vertical distribution of different marine habitats and organisms. Environmental monitoring, modeling the dispersion of pollutants and oil spills. Marine navigator, ensuring buoyancy and stability for ships and submarines. Fisheries management, tracking nutrients movements that dictate fish migration and productivity. The journey of a single parcel of water, whether it rises to the sunlight surface or sinks to the abyssal deep, is dictated by the simple rules of temperature, salinity, and pressure. Multiplied across the globe, these individual journeys combine to form a vast circulatory systems. This unseen engine distributes energy, fuel lives, and ultimately makes our planet habitable. Okay, that's all for today. In this class, we have discussed about ocean density. If you have any doubt and query, just let me know in the comment section. Thanks for watching. Thank you.